Hello everyone. I'm going to talk about some of the basic trig identities. So the first thing, the definition of an identity is it is an equation where both the left side and the right side are always equal to each other no matter what value we plug in for the variable. And a trig identity is just an equation, it's an identity that has some trig in it where both sides are the same. So the first basic identities that I want to take a look at, these all come from just how we define the different trig functions. So the first one, the reciprocal identities. In this case, we know that there are sets of the trig functions that are directly related to each other. We define them as reciprocals. So for example, sine and cosecant are reciprocals to each other. So the sine of theta, this is the reciprocal of the cosecant of theta. Or if we write this the other way, the cosecant of theta, we know that is equal to 1 over sine of theta. And the same thing goes for our other ones. So we know that cosine and secant are reciprocals. So cosine of theta is equal to 1 over the secant. And then going the other way, the secant is 1 over the cosine. And then the last one, we know that tangent and cotangent are reciprocals of each other. So the tangent of theta is equal to 1 over the cotangent. And the cotangent is equal to 1 over the tangent. So each of those just comes from the way that we define our different trig functions. Furthermore, another very basic one is the quotient identities. And again, this just comes from the way that we define tangent and then related to that cotangent. So the tangent, when we're looking at the unit circle, we define this as the y value over the x value. So in terms of our trig functions, tangent is equal to sine of theta over cosine of theta. And then the reciprocal of that, if we flip the fraction, the cotangent of theta is equal to cosine divided by sine. Okay? So each one of these just comes from the way that we defined our trig functions in the beginning. But these are all identities. So no matter what value I plug in for theta in any of these equations, both sides are always going to be the same thing. So now let's use these just in a simple example here. Now we do have other ways that we can approach this, but I want to use the identities just to show you their usefulness. So it says if the cotangent of x is equal to 2 over 5 times the square root of 5, and the sine of x is equal to the square root of 5 over 3, we want to use that to find the cosine of x. So the first thing, I know from our identities, I know that the cotangent of an angle, in this case x, that is equal to the cosine of x divided by the sine of x. And that's true no matter what value of x we pick out. So I have 3 things in here. I know 2 of them. I know the cotangent. I know the sine. So I should be able to substitute those in. That will just leave the cosine, and we can solve for it. So the cotangent of x, this one is equal to 2 over 5 times the square root of 5. And then we have the cosine of x divided by, and then the sine of x is the same as the square root of 5 over 3. So a little bit of substitution. Now the only thing we don't know in this equation is the cosine of x. So let's solve for that. So to take care of this fraction over here, I'm going to multiply both sides by the square root of 5 over 3. So on the right hand side, this will simplify to 1, just leaving me with the cosine. And then on the right-hand side, when we multiply two fractions together, we multiply the numerators, multiply the denominators. So we're going to end up with 2 times the square root of 5. And then 3 times 5 is 15 over this times the square root of 5. And that's all equal to the cosine of x. And then to finish simplifying, the square root of 5 and the square root of 5. So the cosine of x is equal to 2 over 15. So there's our answer. Now, as I said, not the only way we could handle this. I could think about these as the side lengths of a triangle in the coordinate plane, and we could go from there. But this is just showing you, using the identity, we can end up with our answer as well.